My name is Donald Tarter, and this is the second in a series of videotapes that we are producing under the auspices of the University of Alabama in Huntsville and the Alabama Space and Rocket Center, entitled Our Future in Space, Messages from the Beginning. Today we have two pioneers of the original space launch of October the 3rd, 1942, the beginning of the space age with the A4 launch with us. My co-director of this project is also with us, Mr. Conrad Dannenberg. Mr. Dannenberg himself is a member of Dr. von Braun's original rocket team and a longtime resident of Huntsville, and has retired now after serving a distinguished career with NASA and the University of Tennessee Space Institute. Mr. Dannenberg, I'd like to ask you to introduce our guest today.
I'm certainly very glad that I can be joined today by two of the real old-timers. In fact, the gentleman right next to me, Mr. Wernher Rosinski, worked with the von Braun team already before the time in Peenemünde. He joined this group at the rocket test station in Kummersdorf, close to Berlin, and he moved then with that group to Peenemünde in order to continue the activities there. And that's, of course, essentially what we want to discuss today. And next to him is Dr. Hermann. Dr. Hermann had also an unusual position in Peenemünde. He operated the wind tunnel, which did not only serve the rocket activities, but which was also used for a variety of other things. And I'm sure he's going to tell us about that. I think we should now first give Mr. Rosinski a chance to tell us a little bit what the initial activities in Kummersdorf were, what they did there, and then also to tell us a little bit about the move from Kummersdorf to Peenemünde in order to really get those activities underway which we are discussing in this series here. Wernher, would you please say a few words?
Okay. I was interested in rocket research already as a boy, and therefore I really watched what's going on in the years 1929 to 30. And this was a time when already, when Dr. Wernher von Braun was a student at the university and also was a member of that first rocket airfield Berlin. It was called Reinickendorf. On the end of 32, Dr. von Braun was hired by the army, and he started working in Kummersdorf. That's an artillery firing range near Berlin. And when he was hired in, the late General Dornberger, who was a doctor engineer, Dornberger, who was later, after the war, with Bell Aircraft, Mr. Bell hired him, and he was his supervisor. In 1934, was Wernher von Braun and his group had the first success in launching the forerunners of the A3, which they called A2, and there were two boys named Max and Maurice. It had a 660 pounds thrust and had added fluid altitude of approximately 6,560 feet. In 1936, Dr. von Braun and this group, it was a very small group. I transferred to him from the base in 1936, and from the first time on, I was actually the first technician for electrical systems, and really I created the first base for measurements on the static firings. During 36 and 37, we assembled, actually they were on the program 6 A2s, A3 that we built. We actually built 6, but we blew up 2 on the test stand and got only 4 ready for a launch of shore of Peenemünde, which is called the Island Oil. We launched 4 A3s there, and every one was a steering failure. Actually, the power system was working very well, but the steering, as soon as it was lifted up to approximately 100 or 200 feet in the air, it started turning and fell in the water, actually in the Baltic Sea. And this A3 was a real forerunner or scale model, if I would say, for the A4. All the steering systems were tested on the A3, which later on, after the failure of the 4 A3s, they named it A5, and to distinguish 2 models. In fact, the same engine was in it, and it had a different steering system, and everything was improved. And in 1939, the first A5 was launched without a steering system, and to check the stabilization of itself. And all 4 tests or launches were a success. And we continued building the A5 up to 1942, when the last one was launched. And shortly after, the A4, which was later named during the war a V2, we were ready then to go in manufacturing of this for scale manufacturing first for tests.
Mr. Rosinski, may I ask you 2 quick questions? From what you just said, I take it you did never fire an A3 or any other larger vehicle from Kummersdorf? So all the launchings were done
that is correct.
At the Baltic Sea?
Absolutely.
But you did test the propulsion system, so you had a test stand and the propulsion system could be fired.
Absolutely.
But the vehicles were not launched from there.
That's right.
Right. And concerning the control problems, the steering and control problems you had, was it the steering system that malfunctioned or the control system? And maybe you'll say a few words about the controls.
Yes. These were the first control system we actually had in the truss. We had little vanes. These are carbon vanes, jet vanes. And it was later that our specific engineers working on this problem found out that they were far too little to give an impulse on the direction of the flight. So therefore, the first one was just like this, that was the height. And the regular was on this size.
So the design was flawed, and that was one of the purposes of the test, of course, to find out if the design was adequate and if it could do the work.
Right.
On the other hand, apparently from what you said, with some early models like the A3 and the A5, we found a lot of valuable information which could be applied to the A4 and made the A4 from the beginning a much more successful vehicle.
Absolutely. This was the idea behind it, and everything was tested from the measuring systems, what we had in it. We had many more measuring systems. We were a much larger group. I'd like to mention that when I joined Wernher von Braun, I was the 31st member in the whole group. In other words, there were only 30 people. That included Dr. von Braun and everybody.
Mr. Rosinski, you can almost look back 50 years into our present history. Most of the other old-timers we talk to, they have only about 40 years of rocket experience, but in your case it's 50 years. Looking back, what were your ideas at that time? Did you think that we would eventually have a space shuttle, that we would land on the moon during your lifetime? That hopefully, of course, we are going to build a space station right now. What were your ideas? You apparently have been a rocket enthusiast all your life. And what did you foresee out of your early efforts? Can you tell us a little bit about that?
Yes, sir, I can. The first time when I really read the articles, that was in 1930, Professor Dr. Obert, he had an article in the year's manual about rockets, and he said a flight to the moon it will be possible in the next 10 years. And he also gave a cost which was 100,000 mark, which is like nothing. We learned later on that we couldn't even buy the fuel for it. But anyway, this I was so impressed on this article, and then the first time I met Dr. von Braun, he was the biggest enthusiast for rockets I think I ever met in my whole life, and he was really leading his group, that I was not the only one who really thought that one day we will go into orbit and land on the moon. I was sure that one day von Braun will lead us to that, and which he did. Now I'd like to mention I'm still thinking further ahead. 2 years ago I was in New Zealand visiting a friend, and he said, I have a boy in school, in high school, and he's very much interested and asked me whether I could hold a little lecture there, and which I did. I got me some films, and it was not a class, it was a whole school. And one of the basic questions after the film I showed, we had a question and answer period. And the biggest question what hit me was, when will we be able to, just as a visitor to a space agency place, when will we be able to fly into orbit? And just with a minimal cost, or a cost we can afford. And I gave them the answer that I'm pretty sure that just regular individuals will fly before the year 2000. And anyone who can afford it, as it was in the past, airplanes, the first time only the very, very rich people could afford it, but later on practically everybody. And I see a big space station where instead taking a trip to Hawaii, you take a trip into orbit and look at the stars.
Yeah, and you probably have heard that NASA is working already on plans to invite some men from the street, so to speak.
Right.
Of course, in the beginning, probably some professionals, some poets, some artists, some painters, who should then tell the rest of the world what the conditions are in space. Yeah. But the next step after that would be, of course, to really take the normal human being up in space and have him spend some of his time there. I think we should ask Mr. Rosinski still what his impression was at the launch of the V2. You were present at the launch of the very first successful V2, right. And of course we had 2 failures before that, right. But the third launch in October 1942 was successful. You were there,
right.
And what were your general impressions at that time?
And everybody was really, after this launching, enthusiastic that now we got it made to put a man on the moon. Actually, at this time, everybody thought that we got it made now, and it was the biggest success we had. In Germany.
It is also said that General Dornberger, who was of course our overall boss at that time, that he made a statement along these lines. He said, now we launched the spaceship.
Right.
That's right.
That's right.
Conrad, I'd like to maybe actually quote from an article by General Dornberger what he said on the evening of October the 3rd, 1942. And he stated it thusly. He said, "We have invaded space with our rocket, and for the first time, mark this well, have used space as a bridge between 2 points on Earth. We have proved rocket propulsion practical for space travel to land, sea, and air. may now be added infinite space as a medium of future intercontinental traffic. This 3rd day of October 1942 is the first of a new era in transportation, that of space travel. One of the people that was most instrumental in that first successful day of space travel was Dr. Rudolf Hermann. He was in charge of the basic test that preceded the launch of the A4, or sometimes called the V2, that demonstrated the fact that it could safely exceed the speed of sound and perhaps re-enter the atmosphere without destruction. General Dornberger in his article notes also that at the time of launch he was looking toward Dr. Hermann. Dr. Hermann was in charge of observing the launch through a ground telescope and dictating his impressions to his clerk who stood near his elbow. Dr. Hermann is near my elbow today, and I want to ask him quite frankly, as you saw success unfolding before you, were you able to give any intelligible directions to your clerk, or was enthusiasm too much at that moment?
So your question is very good. I was there. We were fully aware, because 2 launches, as Colonel Dornberger said, 2 launches before were unsuccessful, so we were really in the highest tension. I remember exactly my position, very close to the actual launching place, much too close for safety, but didn't care. And I had what is here described as a kind of a periscope. It was actually a kind, like today, a Nikon telescope, a short telescope, which was looked in like this, and it was turnable in all directions and stable in any moment you left your hand away. So very good. And we used this, of course, for many, many years of observations through the launches. The A3 and the A5 from the oil, which Mr. Rosinski just described. So we had quite some practice, and always turning, because we didn't have tapes or what, so we had our impression that it wasn't lost to see it right away. By the way, the clerk was not a clerk, it was a very pretty girl. Because we were sure that the secretaries or the, in this case, the calculator girls, we didn't have calculators, so we had to hire many girls to turn the calculators, and they were certainly.
Mr. Dornberger said that as success was at hand, they all turned to each other and gave each other big bear hugs. Did you turn to this pretty secretary of yours and give her a big bear hug?
I'm sure.
Well, the marking of the beginning of an age is really a remarkable event to live through, and we would like for you to give us as many memories of that event as possible, and as many things as that sparked in your mind as possible.
May I go back a little bit, because you started with your person. I heard the rockets also through Obert's book, which was published in 1925, around 23, second 25. And I was studying at the University of Leipzig. Professor Schiller, S-C-H-I-L-L-E-R, was my very good professor, physics, and aerodynamic, fluid dynamics, heat transfer. And I told him one day I want to make a trip to Berlin, which was 100 miles, but it was having no car. It was quite an event, in order to attend a lecture there at the university in Berlin about space travel and rockets. He just looked at me very strange and said, "Are you not crazy wasting your time with such a thing? It has only sense to talk about this when you know the drag coefficient measured of a bullet or space vehicle at supersonic speed," which he certainly knew because he was an aerodynamicist, had never been done. But that was my illumination. A year later, or 2 years later, I went to Aachen, had the fortune that I was asked to go there to university on a grant. And there, again half a year later, Professor Wissensberger from the famous Aerodynamic Institute of the Technische Hochschule Aachen asked me if I want to join him because he had received money to build a supersonic wind tunnel. I thought that is a heaven, because that was what I'm waiting for, which my former professor said, that's what you need. And there certainly. So I joined him, and I was there for 3 years, from 34 to 37, at the Aerodynamic Institute. And I built there a first small blow-down supersonic wind tunnel, up to already a Mach number of 3.3, that means about 1,000 meters per second, because sound velocity is roughly 300 meters per second. And a 3-component balance, that was the main thing. 2 physicists had already built supersonic wind tunnel of such a small size, a few centimeters, but just to see the flow. So I built a 3-component balance to measure, and to measure what we call, this is my little missile. And here you can think the fins on, and when the air, when it's flying like this, the airstream comes like this. It has 3 types of forces. One, the drag, which is in the direction of flight, it retards it. Then, in the moment when it has angle of attack, it has also lift, which carries up and down. Very important, otherwise you could never have turned the A4 in a circle in order to go wherever you want to go. And then the fins here are very important in order to stabilize it, because they must produce a force here that when it's flying like this and goes up with the nose, a force here on the tail puts it back to 0. So always when it tries to get away from its flight, it is automatically brought back to the flight. You call this stable, but particular aerodynamically stable, because it's the aircraft which produces. Then about what you talked about, those stabilization were certainly with artificial means, which had to come in addition. Now, so, because I had this wind tunnel in preparation, and the first test done, suddenly on January 6, 1936, suddenly a Dr. Wernher von Braun from the Army Ordnance came and visited in order to see me and find out what I could do with my wind tunnel, which he had heard, for his problems. And he showed me drawings. It was very secret. The word rocket would never be used. The velocities or size of rocket engine was never used. And I was said I should just answer the questions. Don't ask questions myself. So I saw immediately from the drawing that it was pointed to supersonic speed was obviously it was beyond here. So that was clear. That was a rocket. That was the end of the rocket. Rocket exhaust. It must be a rocket. And he also said, as fast as I could measure in my tunnel. Okay, I said Mach number 3.3 or 1,000 meters. So do whatever you can. So, I believe 2 weeks later, the first contract came from the Army Ordnance to the University of Aachen in order that I should measure, test this instrument, this first missile.
You described here that complex array of forces that play on the missile as it goes through the atmosphere. Did you ever despair that this might just be an impossible project? Because you were working in the days before the high-speed computer, all hand calculations. It was a laborious process. Did you wonder if it could be solved technically?
I was always convinced that I would solve it. I had many other problems already solved, smaller ones certainly. And so I was also under the very good direction of this Professor Wieselsberger, from whom I learned a lot in not only theory but also how to build wind tunnels and balances, optical equipment. So 3 years later, or not early, yeah, 2 years later, in 37 already, after Von Braun, Dornberger asked me if I would come to Peenemünde, because they started it there, and so I certainly was glad, because then, instead of having a small wind tunnel, 10 by 10 centimeter, with such small models, I could build such a big 40 by 40 centimeter with models like this. The fins you really could see, and the rudders you could put on, and the hundreds of pressure holes in order to measure the distribution of pressure is all necessary for the design people to know what kind of forces are developing at what point of the trajectory, at what time. And only those measurements could do this. So,
do you detect that air of confidence that you had in those days in the program today? The modern missile engineer, do they lack something that you old-timers may have had? Are they as keen on their vision and purpose as you perhaps were?
Oh, I'm sure that my colleagues today, when they, for instance, do a thing like the Space Telescope, which is a tremendous step forward in all directions and requires that they are as keen as we were at that time. Sure, in our times, it was always everybody say, the good man, it will never work. It will never work. Even my good Professor Wieselsberger, of course, who heard all the explanation by Dr. Von Braun, hour-long and so on, he said, I cannot detect any physical reason that it wouldn't work. All the laws of physics and mechanics are obeyed in what he says. But it is so complicated, it will never work. It is so complicated, it will never work. And that we heard many years later from many people, in particular when we heard the first failures, then of course everybody comes up. I told you so. I told you so.
Well, you were certainly one of the people that taught us never to say never.
Yeah, yeah. But in your questions about, I had your
right, some of those questions there that we submitted to you, we'd like to know your feelings about how the direction of the space age has turned out. What's been the biggest surprise to you since your days at Peenemünde and the way the space program has gone worldwide?
Yeah.
Along that line, I also have another question coming back again to what you said earlier. When you look at modern missiles like an MX or an ICBM, or even starting with the Jupiter, you don't see the big fins anymore at the tail end of the missile.
Yeah.
What's the reason, and did we eventually spend too much time in wind tunnels in the early days? And are these kind of measurements still required today? Could you elaborate on that a little?
For every missile of the size of the A4, or even of Jupiter, aerodynamic stability is required. Now, the controls at our time, which we had, and which you mentioned, the two companies, Siemens and Kreisel, they were certainly excellent people, but the speed with which they could produce the controls were much too slow, much too slow. It took them, for instance, 1 second or so from the rubbers vane, as you mentioned, so to 20 degrees or so, 1 full second. Even they had all the motor and the batteries that you tried to control it. That is much too fast, much too slow, because in this time the missile is already so much out of line that the air forces which I mentioned, the lift and the moment, are so strong that it's too late. So the result of those first firings on the oil in December 1937, which also was present from the beginning, all 2 weeks long, was very clear. In fact, one of our friends here in Huntsville, Dr. Willy Heiberg, H-E-Y, B-H-Y, he was at this time my mathematics branch chief in mathematics and trajectory calculations. He calculated in the week, 1 or 2 weeks after the failure, exactly, assuming everything works exactly as scheduled, the gyros, the command, the vanes, it couldn't succeed because the wind was very strong. The wind was about 15 meters per second, which is, I believe, roughly 30 or 35 miles per hour, I believe. And that's certainly quite a wind in order to test the first V2s. I asked Dornberger before that launch at the hall, because the weather was terrible, wind and storm. I said, do you really want to make the test tomorrow? Then, because even in the airplanes, which are old, flew, of course, since 1904, so in 10, 12, 20, 30. Every new time you develop a new airplane, you make flight tests very careful with the best technicians, the test pilots, at very good weather. So I would suggest better wait until the wind is down. His answer was, the military doesn't develop a good weather weapon. Very good.
Dr. Hermann, you indicated that we really made tremendous advances in guidance and particularly control systems. They are much faster, much more responsive today. Is that the kind of development you had in a way foreseen, predicted? Or is it something that surprised you a little bit? And is it an area where we made bigger progress than you had predicted?
Oh, yeah. In this case, this is one of the biggest positive surprises, that the need for faster control systems was obvious for our development from A3 to the V2. But here in the US, I found out very quick the development of control system was so successful and became faster and faster and faster. And so fast that, of course, you know, it's not the location, it's not the speed, it's even the acceleration of the speed. To say so, when the missile just thinks it should make a move. Not makes a move, it thinks to make a move. That is already through the gyros.
Yeah, so we have made really tremendous advances in those areas.
And that made possible that, for instance, in case of the Redstone, which was an unstable missile, that would fly. But going back to Saturn, when Saturn V certainly was a manned program, so at this time, when it was a manned program, I remember the discussion with Dr. von Braun I had here in Huntsville. I was not here stationed, but doing visit and consultation. He also said, with a man in, it would be very safe, so we make some aerodynamic stable. Therefore, the Saturn V vehicles have the big fins.
So they added the fins again for safety reasons in a way.
Sure. In the case of the Atlas missile, which was not certainly our development, they also had no fins. And you know how many failures they had, because the slightest error in the brings catastrophe, because then it tilts over 90 degrees, explodes. Yeah.
In General Dornberger's writings, he alluded to the fact that had this launch failed, had the A4 failed on October the 3rd, since you had already had 2 previous failures, he was thinking seriously about going to his superiors and recommending the end to the project, that these people should perhaps be transferred to airplane and artillery development. Do you sense history in that way? Do you think if you had have failed that day, it might have significantly delayed the development of rocketry? And
I believe so, because as Dornberger describes in his book very dramatically, failure and always try to convince your superior it was this. He found it out it was this, and he found it out it was this. But that certainly has a limit, particularly when we are 1943 and the war was going on in the manpower. So, but as answering your other question, another big surprise in the positive sense, which I found here, was the automatic checkout systems. We, of course, at Peenemünde, we checked it by hand or by brain, point by point, checking. That took certainly longer time. And now, that was certainly through the development of the computers, which we, at least not in my area, nobody could foresee this. Computers, and you know that certainly now the Saturn V and the Apollo vehicle and the mission, total mission, need such a complicated system and constant checkouts that without this, with the computer checkout, probably we may have never done it, or was impractical or impossible to build really a moon rocket. And this we did not anticipate, and that was one of the very glad surprises in your questions.
I think that especially the simulators for Saturn I, we started simulators, and these simulators were partially computerized already. This is when we started, and this is really to having we could make a flight, a dry run flight without a rocket, and this really brought us forward. We saw the weak components we had in our system, whether it was a valve or was an electrical or electronic components. But we ran the simulator 24 hours a day and 7 days a week. And through this, we really could knock out so many failures, which we later found just in flight. We found them out already on a simulator. And I think this is where Hans Fichtner, one of our colleagues, he had this project, and he brought it forward. Really, what we have now is a simulator is at a launching site. We can run the simulator without connecting the rocket, and so they check out the ground system. We had for the checkout of the ground electrical system, we had already simulators in Peenemünde, and we may built them before we went to the launching areas. So then, because the launching equipment was built and then sent to the launching area, I'm talking now with the military mobile units. And so therefore, I mentioned already earlier when we discussed the flight in with actually a military version, we checked the complete system out at home, at the home base, and then we went to the launching area. And so we know the launch equipment is up to par with the rocket itself. And I think this was a great step forward in our whole development.
Speaking of steps forward, if we could get perhaps on a slightly more negative sort of question, what's been your greatest disappointments in the last 40 years or so of the space program? Have there been some misgivings and some disappointments for you?
Yeah, answer. Because your answer is, yeah, disappointments, yes, but not in the direction your question was phrased. Disappointed in the direction to go. No, I would not say you can do this, and then the Jupiter and the Saturn, the Moon, and now the space shuttle. That is completely right. I was disappointed in the speed or the pace of the development. Was too slow, was often interrupted. You here at Huntsville, you knew it, and was probably by waiting for political decisions here and there.
And you talk now even about the period before the moon landing. So you think we even could have arrived at the moon landing sooner than we actually did.
Also first, you know that here in Huntsville you could have launched a satellite much earlier, and you were not permitted by such and such reason.
Political and funding.
Aber auch funding certain orders, but also political and also army, navy. But that is, I believe, also documented by books, for instance, by Medeiros, who fought certainly a big fight for this. Now, so that is the action. Certainly we were, I would say, spoiled somewhat in Finland because it was war and it was a military. So once there was a need, a decision was made, and the decision was made by General Dornberger, or when he had to go to his superior, General Late, whoever was the commander. And he said yes, okay, Dornberger said yes, and at that moment I said yes, and everybody worked up to here. And that was certainly, to say so, spoiled.
Mr. Rosinski, you share that disappointment in the speed of development, even though that most people would consider it's developed at a lightning pace.
That was not only here, it was also during the war. You know that our highest official in the government, they didn't know whether they can trust us and that we bring something really suitable or possible in this war, and therefore we had certain budget categories. We were Group AAA, which was the highest priority, and we were just the end. I think we were maybe A, and then we dropped to B, and every time we had problems, you know, then we dropped. That's actually what happened there too. But what really I think everyone in our group agrees with me, the first 5 years we did not spend really toward our project that we later want to be in space, and we were in wide sense, we were just launching V2s just for the public and for the universities, and sure there was some research in it, but it didn't bring us any step further in the 5 years from the V2 into the next generation, and which was a Redstone. We could have started the Redstone or even bigger if we had the funding right the first year when we were here. And this, I think everyone now, our group of the original team group, and those what came later, agreed with me on this.
This also brings up another general area of questions. Of course, when we all came over here, at least most of us were attached to the US Army. I think Dr. Hermann came under somewhat different arrangements.
Air Force.
You came with the Air Force, but they all were military departments. And of course, when we came over, I personally at least expected that we would keep on working on military projects, on military rockets, maybe even real big ones. People like General Medeiros had plans to build a base on the moon, to survey the Earth from the moon. So it doesn't necessarily limit the size of the project. But I really had expected that our continuing activities would be somehow Defense Department related. Now, of course, when Kennedy said in the early 60s, let's fly to the moon, that thing changed drastically. In fact, it had changed when President Eisenhower decided to establish a civilian agency, the National Aeronautics and Space Administration. Is this one of your surprises? Had you expected this kind of thing when we came over? Or was it something that was a brand new development?
That was actually what we all thought. We coming up one day. I mean, as von Braun already several times said in his book, My Life for the Space, he always said we had to go through the military because no private agency was capable of for such a big project. We had to build weapons first and then spread out for space work. And that was the same. Wernher von Braun was not too much interested in building a war rocket, but that was the only way that he could further go up and go into space.
That leads us to some interesting questions about present-day space activities and the debate over the militarization of space activities and which direction it should go from here. President Reagan has recently proposed a Star Wars program. Some people say this is too much militarization of space. What are your views on this regarding militarization of space in the future?
Well, if I can say something, I think that depends very much the foreign political developments. We just cannot say, even we are a good size of nation here, and that we say we all want space programs for the civilization, while the Russians have already a spy, you can call it, definitely is something like a spy orbit vehicle, a space station. I see only lieutenant commander and would fly up there now. Of course, they take their people from their communist nations up for a flight. But I noticed, and I think in the last years, that they do very, very little for realm or space and development as for military. So therefore, we have to keep up with our east neighbors.
That surprise, you think almost a natural development.
Absolutely. This is what I think that we have to live with. Let's put it this way.
Dr. Hermann,
how do you feel?
I agree fully with what you said. We have to have, say, what you call the space activity in the military arena. We all know that war is most deplorable, and all countries on the globe should do everything to avoid future wars. And we know that there is the United Nations since many, many years. The framework and the tool to settle the differences. But we also know how little it really does. History shows that every human race invited, from the first club which the ape man tried to kill the deer in order to have food. The same club he used the next time to his neighbor who tried to steal him the food he needed. And that goes on, and certainly the most beautiful invention was the art of flying, and people was that hundreds and hundreds of years tried to do that. And finally the dream was fulfilled. They could fly like the birds, enthusiastic, but you all know it was immediately used in World War I. could hardly fly. Oh, they used as fighter or as bomber, put in a few pounds of bombs. Fighter and bomber were immediately used. So, and the same will be in space. Once you are there in space, know the laws to obey and to operate vehicles in space. It will be used for the purpose of war. The opportunities and the advantages of being in space and overlooking everything else are so strong. And everybody, every country who has a mean will use it. And as you say, we know that the Russians are already doing it and advancing it. So our space activities and the military, I would say, should go full ahead. Otherwise, we are too late and are only losing. Yeah.
I think one of the biggest accomplishments we have just from the last flight that we picked up a satellite, hauled it in, repaired it, and put it back in space. I think this was a one-time and really a great accomplishment, I think, for this nation. Absolutely, because we have so many space vehicles now in orbit already and more coming. And in the past it always was a loss because the telecomputers and what have you, most of our telephones depend now on the satellite because TV and everything. And if we lose one like this, that goes in, that's probably a development for 2 years or more, and not counting the money. And if we can do this repair, that is a big step forward into history.
Our time is beginning to run somewhat short for this interview, but I would like, before we end the interview, to ask you to try to imagine the future. One of the purposes of this project is to get those pioneers of this age to speculate on that which is yet to come. And we hope that future generations may refer back to your ideas and your opinions with a great deal of interest as to what do you foresee to be the most significant developments that are likely to come about, say in the next 25, 50, or even beyond, if you care to speculate, 25 to 50 years or beyond. Mr. Rosinski?
I think that a space laboratory is really the thing we should emphasize is needed for the near future, because there are so many developments or investigations in medical and chemical and medical supplies, which they cannot be very well made, and they found in a weightless area, and also in actually in an airless area. You can produce and manufacture some certain things what you couldn't do on Earth. And to then this, I foresee in the real future that maybe some kind of surgery is better be done in space as down on the Earth here. And these things, I'm pretty sure that 20 or 30 more years from now, that you have not a space station, you probably have quite a few. And the exploration of the further stars actually and solar areas. This is so interesting for the future to look at it, that is absolutely necessary that you start your flight from the space station and not from Earth.
Right. You mentioned examining the stellar objects and so forth. Dr. Hermann, of course, has taught courses in astronomy at the university for us for the last several years. Would you care to comment on the future of space astronomy, Dr. Hermann?
Yeah, Number one, I wanted also to agree completely with you that space station, that's certainly our number one project. It's nearly, and Marshall Space Flight Center, we know, has made exact proposals, and we hope that one of them will be adapted. But for whatever is done, which project space station must be done as number one, immediately, without waiting, with sufficient money. And as Marshall Space Flight Center says, that let's say for 10 years the first, and immediately after the second decade, it will grow more people, more power, more laboratories, and the laboratories you mentioned, for material and also for medical purposes. I believe that maybe certain sicknesses on the ground, people working in space or living longer time in space, they will have those old sicknesses, but maybe they get new ones in addition. But otherwise, maybe some space condition like weightlessness, very clear air for people with breathing difficulties also. And so that, and one of the also of the space station in the Marshall proposal is also certainly astronomical observation. In fact, the independent of this is here developed at Marshall Space Flight Center since several years, the Space Telescope, which will be roughly launched about 85 or 86 with the space shuttle and port up. And the advantages will be tremendous in the observation, because the air isn't there, the stars don't twinkle, and you can use very, very sharp picture. Then we will get so many new data. Suddenly we will see about 300 times as many stars as we see now have. So what we know now will be only a small fraction. Yeah, I believe that.
This may indeed change our ideas about the whole origin and evolution of the universe.
Yes.
With one technology.
Yeah, yeah.
Well, we only have just a couple of minutes left in this interview, and we'd certainly like to perhaps ask you two gentlemen to make a sort of closing statement about the significance of your life, the role that you've played in the development of this exciting new age of space exploration, and leave us with a thought that you would like to leave for future generations as to the role of space in human activities. Mr. Rosinski, would you like to start?
Well, I hope that we really progress in the way, and maybe a faster way as we could in the past. And this is, we really, after first coming into space, we really learned that the world, the universe is really a universe. You don't know where the end is. And this is, I think, you don't have to be enthusiastic about stars. And the last 50 years were a technical explosion, I may say, on this earth. And that may be even further and bigger explosion in the next 50 years. And we really hope that our people would come after us, that they follow the course and go ahead and develop whatever is possible.
Thank you. Dr. Hermann, do you have a closing statement?
Yeah. I remember very well the date, December 1937, on this little island, Oi, where the first launches were made. And before the launches, I went there and surveyed myself with my eyes and surveying instrument, the place from which the first rocket would start, order to have the exact coordinates, geographic longitude and so. And I said to this time, when I finished it, to my associates there, this is a historical moment. This from here will start the first rockets. The first ones, smaller ones, they come and fall back to Earth. But then the bigger ones, they go into space and never come back. And the next important point, I believe, was July 1969, when the Apollo 11 crew landed on the moon and walked. I believe later in history, when many facts are forgotten or unimportant, mankind should remember that men left the globe the first time and walked on another celestial body in July 69.
Right.
Thank you. It's almost very difficult to envision the impact of the age that these gentlemen have helped usher in. It's time now that we must end this interview. This interview will be part of a series of documents available at the Alabama Space and Rocket Center and at the University of Alabama in Huntsville Library. I do want to extend my sincere thanks to Mr. Dannenberg, our co-director, to Mr. Rosinski, and to Dr. Hermann for joining us today. Thank you again.